Hello, in this video I'm going to go over the tech specs for the Super Nintendo and the Super Famicom, as it was known in the USA. So let's get into it. So Super Nintendo was released in Japan in 1990, in North America 1991, and the rest of the world in 1993, with Europe in 1992. It has a Ricoh 5A22 chip, which is based on the WDC or Western Digital 65C816, which is a 16-bit processor. It has a number of different modes that it can run in. The two that I'm putting up there is slow mode and fast mode. It changes these speeds depending on the background mode that is selected for it, as some are more demanding on it than others. So it has 128K of work RAM. It has 64K of video RAM, which is split over two 32K chips. It has 512 bytes of color graphics RAM. It has 64K of ARAM or audio RAM, which is on an SPC 700 sound chip by Sony. So on that 64K it needs to have sound drivers, which is some code to make it play different digitized sound effects and different tracks and stuff. So unlike the NES, which had programmable sound channels, this has none of that. It relies pretty much on digital sound samples to output everything. And it supports a number of different resolutions. Again, these are background mode dependent. So normally it's in 256 by 224 in NTSC regions, so that's Japan and America, or 256 by 240, or in PAL regions like Europe and the rest of the world. And you can also get it into a high resolution mode, which will display at 512 by 448 or 512 by 480. So the NTSC display runs at 60 Hz due to the smaller display, and the PAL regions runs at 50 Hz. So like all the consoles of its time, its display is built of using tile sets arranged in a tile map to create the display. So the SNES has the option to change the size of these tiles, which is interesting, and allows the tile maps associated with them to double in size, which is good for a programming side. So colours, the SNES can choose from a full 16K, or rather a 16-bit colour palette. So it has 256 15-bit colour palettes. Normally 128 are for the background tiles and 128 are for the sprites. It uses the exact same colour format that the Game Boy Color uses. So I will now go into some of the background modes. So some interesting things on it is that the amount of background layers that you can have are mode dependent, and this table here I'm showing you here. These are the mode numbers 0 to 7, with obviously a variation here. This is an extended background mode here. So there's all sorts of different parameters you can add to these background modes. There is a whole load of YouTube videos by Retro Game Mechanics Explained, which go into a lot of detail on the variations of these background modes. I will leave a link to his channel at the end of, or rather below, for you to check out these in more detail. So strangely, the NES allows you to use 4 colour tiles as well as 16 colour tiles, but it also supports the ability to have 128 colour tiles as well in certain modes, or rather I believe that's 256 colours there in a tile. So in mode 0 you can have 4 background layers. The catch is each of the background layers only support tiles which have up to 4 colours, and the tile format is exactly the same as the Game Boy. So if you've been playing around with any of my, or if you've seen any of my other videos on the Game Boy Color, then those tiles will work in the Super Nintendo in these layers here. And then in mode 1, so mode 1 apparently was the one most used for games, you have 2 background layers which support 16 colour tiles, and then 1 layer which supports 4 colour tiles. At the end of this video I'll give a demonstration, and this is the mode that this demonstration is in. There's variations to these modes. So for example, in mode 1 here, in the normal format, 1 is on top, 2 is below that, and then 3 is at the bottom. But we can change a setting to put 3 on the top. So you can use 3 as like a heads-up display area, and then the other 2 layers as standard sort of backgrounds. So another interesting thing about the background layers is they have independent tiles from the others, or you can choose to share tile sets between them. So that allows you to have, as I will show in my example after I've gone through the specs here, that allows background layer 1 to have its own tile set independent of background layer 2. So the tiles can be, the tiles in the tile set can be in the range of 0 to 1023. Obviously, however many tiles you choose to use will obviously eat up a big chunk of video RAM. So another thing you need to do with the background layers as well is you need to tell the SNES where in its video RAM the background layer will have its tile map, and then you also need to point to another area where the tile graphics will live. So as you can see, mode 2 has just the 2 background layers, 16 colours. Mode 3 has one 256 colour layer and a 16 colour layer. Mode 4 has 256 and a 4 colour layer. And then 5 has a 16 and a 4, 6 has a 16, and mode 7, which is the mode you'll all be familiar with if you've seen Mario Kart, supports one 256 layer, or if you have an extended background set up for that, it will also have a second layer of 128. So there's a lot more that these modes can actually do. There's a reason why they leave stuff off here. There's additional settings you can add on to these modes, which I won't cover in this video here. This is just to kind of quickly go over the sort of specifications and maybe to interest you a bit more in these. Yeah, so as I was saying, the background tiles, they can change their sizes as well. So on most other consoles they're only 8x8 pixels in size, but the SNES can change them to either 8x16 or 16x16 or 8x8. So the tile maps can be either 32x32, 32x64, 64x32 or 64x64. Now if you change the tile size to say 16x16 pixels, then the tile map, if you set it to 64x64, actually has just doubled in its physical size, as each of those entries in that tile map now points to a 16x16 tile, not an 8x8 tile. So that allows us to have larger displays to work with without having to worry about scrolling in images or tiles from a level. Now I'll jump into the sprites here. So the sprites, they obviously rely on tiles like everything else. So if you change the background modes to like a high resolution setting, that has no effect on the sprites at all. So the sprites will still be in like a low res mode. So they are completely independent to anything you do to the background layers. For example, if you choose mode 0, which has 4 color tiles, then it won't affect the sprites at all. So the sprites only ever rely on 16 color palettes, and a sprite can choose one of 8 different palettes. And they're more limited with the tiles, though you can only have a tile between 0 and 511 for the sprites. The way they are kind of organized in memory is a bit complicated, so I will leave off going into too much detail until I do a specific video on sprites, or OAMs as they are referred to by Nintendo. So you can have a maximum of 128, but only 32 can be on any one horizontal scan line at a time. So that's on the either on the display on screen or potentially overlapping the display going off screen. And they can be any size from 8x8 up to 64x64 in size, but you can only choose 2 sizes for all of the sprites to use. So a common size would probably be 16x16 and maybe 32x32, or possibly 8x8 and 16x16. So I don't think there's anything else I want to cover on the sprites now. So I will now jump into my demo to show off my mode 1 example. Okay, so here we are in the demo here. What you're looking at here is a picture of the SNES in the background here, which I've converted into tiles, and then a doctored evil princess on the second layer, and then on the top layer we have the font, which is using 4 colors. So if you hold down the A button and then using the D-pad, you can scroll her around and you'll see that she's seamlessly moving over and below the other layer, and then you can see an actual picture of the Super Nintendo converted into 16 colours there in the layer below. And then if we go into debug mode here and then have a look at the tiles, you'll see she's on background layer 1, and then the Super Nintendo image is on background layer 2, and then background layer 3 is the Hello SNES. And some other important things to look out on here, which is useful, is it tells you the mode, if you like, that the layer is in. So this is in 32 by 32 tile mode. It tells you the tile size, which obviously isn't really that important in this demo here. The demo I was going to show was using a different mode 5 with a high resolution mode, but I decided that this would be a better demo to go for, as it has more colourful images on it. So you'll also see the tile set address here as well, which is quite useful. So that tells you in memory where these things are. So you've got the tile set address and the tile map address. So as these are using, I think there's more than like 600 tiles for this image here. So you need to move the tile graphics pointer to different areas of the VRAM to be able to accommodate these large images. Same with her, she uses over 336, I believe. And then if you look at the tile viewer here, what we're looking at here is all of the VRAM, and then we can change the format between 2 bits per pixel, which is the 4-color mode, or 4 bits per pixel, which is 16-color mode. And then you can scroll down through all of the memory on the PPU to see where things are. So you can kind of, so these are all of the color palettes that we can use here. So she is actually using color palette 2. So depending, in fact no, it's color palette 3 actually. Yeah, so another weird thing which I'll kind of briefly touch on is in mode 1, if you're having a 4-color mode selected, then you need to set the colors for that at the very start here. So these first 2 palettes, if you like, so these 2 palettes here would really need to be allocated specifically for background layer 3, as that's the only colours it can actually see are the first 32 there, whereas the 16 colour tiles, they can see anything from 0 up to 7. So if I carry on down now, this is the you'll see that there's just enough space here before the next image appears, which is the SNES here, which is taking up all of those there. And then if you scroll down to the bottom, a video RAM, there you go, you'll see the font I've got there. So I've got normal small font here at the start of the tile graphics for background free, and then just behind it there's enough space for me to put in the 16 by 16 all caps font set. So using Mesen-S or the Mesen emulator is definitely worthwhile to see where you've got everything. So when you are playing around with your programs, it's always best to make sure that things are residing where you expect them to in VRAM. So that's pretty much all I want to cover for this video here. I will do a few more videos on the different background modes on the SNES before jumping into using sprites. And then the most complicated one will probably be creating sounds and how you would sort of get some music out of the SNES. So the source code I've got here, I will post up for you to have a look at here. So one of the key things on this which was catching me out was I forgot that I needed to have this line put in here. If I see anything to do with console, I normally associate that with the text console in a window, whereas yeah, that's not that. You need a console in it always at the start of your programs. And then if you've seen my other videos, you'll recognize lots of the functions here already. I've got key press and key was pressed as per the others there. So this is only reading joypad 0. And then I've mapped the buttons to that of the GBDK ones here. So it should allow programs to seamlessly jump between them both more easily. And then one thing I've had to do here is, because of the way that we need to sort of set everything up for the backgrounds, I've created an S2D manager sort of load of modules here. So these here set out where in VRAM we want our map addresses to reside. So we have to create arrays in RAM first off. So there are some good things about that. It means that we can easily peek and check what tiles are at what locations in our tile maps. And then we can easily update them as we see fit. And then once we're done updating, we then need to DMA these to their respective locations in video RAM during the vertical blank period. So another weird thing as well is these aren't actually byte addresses. These are word aligned. So what that means is that is actually address 00 there. This is at hexadecimal address double this, because this is not a byte reference, this is a word reference. So a word takes 2 bytes. So this is another weird thing to kind of get to grips with when working with the SNES, is when you're setting things into VRAM, the address you need to set is in words, not in bytes. So what that means is this is actually double. So this number, that is actually 1024, but in VRAM that is actually 2048. So the tile maps are 1024, but each tile in a tile map is actually a word or a U16, which is 2 bytes. But the way you send these memory addresses via DMA is by using words, which is it's kind of complicated. You just got to accept that the whatever number you're going to send in, divide it by 2 to get the word address for it, and then to convert from bytes to words, just times it by 2. That will give you where it really is. And then, like I said, each of the background layers, their tile sets are at different memory locations. So sometimes you'll need to play around with that to get things where you want them to be. I won't go into too much detail here. I will obviously create like cover most of this in another video. For example, the tiles, each number in here is obviously split into the into like bit flags, if you like. So each tile can have a palette number associated, a priority flag, which is either on or off, a flip vertical flag or a flip horizontal flag, which is what this is used for here. These macros here to create similar things that the we have in SGDK on the Mega Drive. So these are just some simple commands here which should get you up and running quickly. I'll post a link to the source code, and I will see you in the next video. If you've got any questions about this, then by all means drop them below and I'll try and answer them if I can. Right, that's it for this video. Catch you later.